Okay, so let's go ahead and finish off macromolecules 1. All right, so we just finished lipids. Let's look at our fatty acids in a little bit more detail. All right, I mean, we finished our triglycerides. Let's look at our fatty acids. Okay, move some stuff around that you can't see. Hang on just a second. Step out of the way. All right, go away. All right, so our unsaturated fats, these usually come from plants and fish. Okay, they are liquid at room temp. So, you're looking at your different types of oils, fish oils and plant oils, things like that. They are, again, going to be liquid when they're sitting at room temperature. And then we have our saturated fats. These are usually derived from or contain animal fats. And these are solid at room temperature. So things like butter, bacon grease, Crisco, lard, any of those things are going to be saturated fats. Let me pause here and talk about where these terms saturated and unsaturated come from. Right here, what this means for something to be unsaturated, it's actually referring to the number of hydrogens that are attached. So unsaturated fats do not hold all the hydrogens that they can. They're not saturated with hydrogens. There's an example of this here. You can see that we've got hydrogens up here, and we probably even have them over here, if this is the end, but we're missing them here. So they're unsaturated. The fact that they're missing hydrogens actually changes the shape of the overall molecule, which you can see here. It makes them bend, okay? Because they bend at wonky angles, you can't stack them, right? Because they're not stackable with this weird angle that they have. And that's why they are liquid at room temperature. They can't stack. But then we get over here and we look at our saturated fats. Let's say that these have hydrogens on the end. They are saturated with all of the hydrogens they can hold. Okay, so there aren't any carbons that don't have a hydrogen. Because they're saturated, their tails are in straight lines, which means they stack really well, okay? And that's why these are solid at room temperature. Your unsaturated fats are better for you than saturated fats, okay? Then we have something called trans fats, and these are not health friendly. Trans fats are artificially created, so they're essentially oils, okay? We'll say like a vegetable oil that has been artificially hydrogenated. I'll explain that. Hydrogenated. Okay, basically what that means is you take an unsaturated fat, something that is missing hydrogens, and then through a chemical manufacturing type process, you add hydrogen to it, okay? So you force there to be hydrogens there where there aren't naturally. This is done because it increases the shelf life of foods, makes them last longer. And obviously for manufacturers, you want them to last longer so that you can sell more. Trans fats can also give what would otherwise be a little more crunchy. It can give it some softness. So like your chewy or chewy cookie, shoot, I can't think. What are they called? Chips Ahoy. Chips Ahoy. Chewy Chips Ahoy. It gives it that chewy texture when this is added. So you're gonna find it in a lot of processed foods. Okay, let's continue. So health implications of this then, we've kind of talked about it, but the fact that you're taking something that's been a liquid, you're forcing it to become a saturated fat, these are what have more of the propensity towards clogging arteries. Okay. They can also have a very negative impact on your not good cholesterol, if you will. So anything that's going to be saturated, not going to do so well when it comes to your health. And the trans fats for sure are great. Questions of the day. Where do excess fruit smiles go when you eat them? I talked about this a little bit, but this is something that gets stored as glycogen in the liver, and then eventually it gets converted to fat. Okay. All right. A little bit left here. Let's talk about phospholipids, our third type here. I find phospholipids fascinating because they are what make up the membranes around our cells. And our cells are super good at keeping some things in and keeping other things out. And it's because of the way that phospholipids are assembled. So I'm actually going to take you over here to look at this first. Phospholipids have something called a phosphate head. That's what this is. It's a phosphate. Okay. The phosphate head is both hydrophilic and polar. So it likes water and it's polar, also like water. But then we have the lipid tails, these guys. Okay, and again, because they're lipids, we know that they are hydrophobic and they're non-polar. This is an interesting combination because you've got part of the membrane that likes water and it's great with it, and then part of the membrane that hates it. Phospholipids in a cell membrane form something called a bilayer, meaning there's two layers, right? So the first has phospholipids that are have phosphate heads pointed into the cell. Then notice that the lipid tails line up in the intermembrane space. And then you've got another set of phosphate heads that are facing outside the cell. Okay, so then let's think about something that's trying to get through this membrane and into the cell. Well, it's going to have a hard time because if the phosphate heads like it, great, it can get past the hydrophilic polar heads, no problem. But then it runs into the lipid tails, and the lipid tails aren't going to let it by because they don't get along. Okay, or we can go the other way around. Let's say that the lipid tails would be fine with it, but they're not going to make it past the phosphate heads. Okay, that's what allows our cell membranes to be selectively permeable. In other words, they get to choose what gets in and out. For everything else that can't just cross the membrane because of the phospholipids, we have transport proteins, and we'll talk more about that when we get to the cells. But for now, let's go ahead with our phospholipids. So phospholipids are going to, like I just said, make up cell membranes. And those cell membranes are called the phospholipid bilayer. So again, we've got the phosphate head, hydrophilic and polar. And we have the fatty acid or lipid tails, which are hydrophobic and nonpolar. Okay, and we'll talk about these a little bit more again when we get into the cell. All right, let's finish off with steroids. Steroids are made very differently. They have a very different structure from the other lipids that we've already talked about. But an example of steroid is cholesterol. Okay. Cholesterol is one of the other types of things that's embedded in this phospholipid bilayer. And of course, we know that health-wise, we look at our HDL and LDL levels to kind of gauge if there's things we need to change as far as diet. These cholesterols are the building blocks for hormones. And of course, a lot of times when you think about hormones, you think about the sex hormones like testosterone and estrogen. Hormones are signaling molecules. We have lots of different kinds in our body. We've got thyroid stimulating hormone that helps with the regulation of our thyroid. There's stuff that's secreted by pituitary glands. We've got all kinds of different hormones, but again, examples are testosterone, which is the male hormone, the male sex hormone, and estrogen, the dominant or primary female sex hormone. I want to talk for just a second about testosterone in the setting of anabolic steroids. Let me switch here for a second. Okay, so anabolic steroids are made basically as synthetic testosterone. Okay. So when we're speaking about this type of synthetic hormone, we're obviously looking at more of a male population who's going to be wanting to use it, because the male sex hormone testosterone is responsible for the development of secondary sexual characteristics, okay, like estrogen is for females. So, you know, the muscle development and energy and hair growth, all kinds of things are really closely associated with testosterone levels in men. So for men that want to bulk up, but their bodies may not naturally be genetically predisposed to being able to bulk up a ton, you know, can want to use anabolic steroids. It increases the amount of testosterone in the system, which allows that type of bulking up to take place. And can increase energy, things like that. The problem is with anabolic steroids, since they're not real, they really throw off the balance in the body, okay? So let's say that a male is producing a normal amount of testosterone, but he wants to, you know, be more athletically inclined, right? Or he wants to bulk up so that he performs better athletically. So he starts taking synthetic testosterone. The body recognizes that there's been an increase in testosterone in the system. And so it's like, whoa, this is way too much here. We need to cut back. So it tells the hormone producing parts of the body for testosterone, it says, you got to scale back. So the body's natural testosterone production decreases. That means that now the person is more dependent on the fake steroid, the fake testosterone, because their body's now making less. So they have to increase how much fake steroid they're taking. This continues until the body can almost not be producing much of any testosterone. This obviously has some issues because then once the person is no longer taking the steroid, the body's not producing it. So now you've got more issues besides just not being able to bulk up. You can have significantly increased levels of bad cholesterol. You end up with something called roid rage. I remember that as a kid in the 80s. I remember the term roid rage. Basically, it's crazy hormone mood swings that can be super aggressive. You have issues with sexual function and performance because of lack of testosterone being produced. So you get kind of shrinkage that can be long-lasting / permanent. You can have voice changes, you can have increased hair growth, and all kinds of stuff that's just not good, because when we add too many levels of synthetic things to our body, it throws off what our body's naturally producing. Having said that, let me say that if we're talking about steroids like the type that are in inhalers for breathing, or if you're having to take an oral steroid for an infection or for arthritis or something like that, that's not the same type of steroid as testosterone and estrogen. There's lots of different types of steroids. So again, things, your breathing inhalers and the pills, the like prednisones, things like that, not the same type of a steroid. And obviously used in a medical setting, the side effects that can result from that type of steroid use are going to be monitored. Okay, so that's the end of Macromolecules 1. Thank you for hanging in there with that. There are days where trying to get all of my technology to work together to put these lectures together, I don't know, it's just like not happening real well. So thanks for hanging in on the days where it's like that. I will have your Macromolecules 2 lecture up soon, okay? So I hope you have a good rest of your whatever, day, night, don't know when you're watching these, but have a good rest of whatever is happening right now for you. And I'll talk to you soon.